Kind of got that backwards. I'm Bobby. This is Jeet.
I didn't know where you were. Behind you.
Bad AI. All right. So just a brief introduction. So I'm Bobby. I'm a senior animation programmer at Ubisoft Montreal. In the past, I've worked on the Hitman franchise at IO Interactive.
My name is Jeet Shroff. I'm currently the lead programmer at Avalanche Studios, working on Just Cause 3 in New York. Prior to that, I've worked on FIFA at EA and on Far Cry 3 at Ubisoft Montreal. So we're here today to talk about relaxed NPC behaviors, how NPCs interact with the world in a relaxed setting, and how they actually react to the world as well, which is a huge sort of area. So the first thing to talk about is really why bother, right? Well, relaxed behaviors are essential in creating a world that feels real and believable. As game developers, we tend to spend so much time in crafting these super amazing photorealistic environments. And relaxed behaviors bring life into that space, which is an essential component of immersing the player and keeping him or her engaged. Apart from the obvious stuff, a lot of games heavily rely on relaxed behaviors to impact the overall gameplay experience. You can think of games like Far Cry or Shadow of Mordor, where the relaxed staging of behaviors, it determines the player's attack strategy, the player's decision-making. Games like Just Cause or GTA can use the relaxed setting as a way to sort of give the player this amazing playground, for the player to poke around the simulation and kind of see and enjoy the different responses, explore and encounter various things. Too often, we tend to focus on sort of high-stakes combat, which is pretty fun and awesome, and we forget the impact that these behaviors can also give us. Finally, a not-so-common and something that I wish we did more of is this idea of an in-game narrative. I believe relaxed behaviors can give us an interesting opportunity to drive and communicate the narrative, both of the world and the game, outside of that sort of traditional cutscene and cinematic approach. And you can use that in combination with it. And this is one of the things we encounter and we tried to tackle when developing Just Cause 3. So as Bobby and I started to put this talk together, we began to realize that in our experiences, we've sort of tackled this problem of realizing relaxed behaviors in different games and different genres, with definitely slightly different needs. So in games like Far Cry, for example, there are spaces and environments that have groups of NPCs that are kind of more evenly spaced out. And they're sort of spaced out maybe for gameplay reasons, and such as towns and camps and settlements, things like that. And the space itself has sort of a overall high-level context. In games like Hitman, for example, you have huge crowds of NPCs. And this crowd is occupying the space with a very high volume and high density. The space itself could be quite large, such as a city that has lots of varying contexts within it, such as a hospital, a police station, a park, all of these kind of varying things. Now, what we found interesting was the commonalities and differences that existed in both these scenarios, both in both the problems and the solutions that we can apply. It's important to know that the solutions you work on need to sort of account for the game and also this kind of concept of scale you're going to have to deal with. And we'll try to highlight this throughout the rest of the talk. So now that we've defined sort of our environments and we've sort of laid out the framework, we need to populate that environment. And with that comes a few, big and small challenges.
So, as Jeet said, we have these varying environments. They can be quite vast in scale, and obviously we need a lot of content to fill them with. And that leads us to our very first challenge, that is simply the production cost of these environments. I mean, this is true for AAA or indie, it doesn't really matter. We have big environments, we've got to fill them. Obviously, there's several costs to this. First is the cost of the actual creation of the environment, as well as all of the props in it, all that kind of setup. Then for us especially, we have the secondary cost of authoring all the behaviors for the environment, everything that we need to do, and then setting it up within the environment. We're paying that cost all the time. And finally, we have the cost of actually testing and tuning. And this is a cost that we keep paying throughout the entire production. So with these three costs, they can quickly add up, and they can get to a point where they can even cripple a production. So as we get close to shipping a title, we end up in a situation where potentially if something doesn't feel right or it's not working all the way, we can't really change out the content, we can't really adjust much. So at those points, sometimes you have to make the shit decision and kind of cut the And none of us want to do that. So what we want to do is we want to try to kind of find a way where we can work smarter and not harder, and kind of invest in better systems that allow us to kind of iterate faster and build our content much cheaper. Another challenge that we have, especially in terms of the ambient AI, is one of variation and repetition. Everybody's played a game where they've entered the level and they found a bunch of these NPCs standing stock still doing the same action over and over and over ad infinitum. You know, it breaks immersion. It looks robotic. Secondly, we have the other problem, which potentially is even worse, is that we have such a small amount of interaction behaviors that when a player kind of messes with an NPC, he kind of responds in the same way. Doesn't matter what character it was. Was it a cop? Was it a vendor? Was it an NPC? They all kind of say, oh, you bumped me, you bumped me, you bumped me. We want to get rid of that. It kind of gives us feel that this big open world with all of this expensive content is reduced to this small robotic playground. And it is, from the side of the devs, but we don't want to convey that to the players. The final challenge we have is one of transitions and interruptions. As we sort of transition behaviors due to environmental impact, due to player interactions, that kind of thing, we need to smoothly transition between these behaviors. And even worse is when we kind of interrupt these behaviors. Not only do we need to kind of smoothly transition out of what we were doing, we need to then deal with that situation and then smoothly transition back exactly where we left off, the previous action. If we were making a cocktail, we get interrupted and come back, we don't restart the whole thing. So these are the basic challenges that we share across all spaces. And this is the kind of the very first step in building any kind of and populating an environment to understand the challenges. And now the next step is actually building this. And the very first component of that is movement.
All right. So Bobby mentions our basic relaxed behavior is now let's move around. In my experience, general behaviors like roaming around is something that we want to limit when we have sort of this smaller identifiable number of NPCs. Instead, it's better to focus on this idea of goal-oriented movement. NPCs that are moving around kind of have to have this reason to do so. This is kind of a focus area for all the relaxed behaviors in Just Cause 3, and it translates better to this type of setting. We still do use, this general roaming around to add dynamic motion and flow to connect up with, the groups of NPCs that are part of that space. But the key takeaway here is to limit the general roam around. So when we do use this general roam around, we use a layered approach, and our first layer defines movement using the environment itself. This makes the movement obviously very believable, but it also allows us to drive that behavior simply by annotating the environment, annotating the world. So in the case of towns and settlements in Just Cause 3, we use our sidewalks and what we call our road network. Now, as a world designer lays out the sidewalks within a town or settlement, this compiles out to what we call a road graph, where each node in that graph is a spline. Every graph edge then defines connections between splines, and then NPCs that are asked to roam around sample this data at runtime, pathfind along a random width ahead of that spline, and then just simply walk along the sidewalk. For sections where we want the NPCs to pass through that aren't laid out with sidewalks, such as, say, a courtyard, in this case, we author flow patterns that help control sort of the paths and connect up, two different sidewalks together. On top of this, we use a layer of pseudo-scripting, and this is mainly for designers to lay out sort of specific paths for the purpose of gameplay or narrative staging. So, throughout the presentation, we'll build up our relaxed behaviors, and we'll show you kind of how we prioritize and choose to stack them with all the various sub-behaviors within it. So far, NPCs that have nothing to do simply move around the space in this way. But what about the crowds?
Well, it's funny. Ironically, in terms of crowd, we pretty much only rely on the roam around behavior. Everything that we have in our role-based stuff, like the vendors and the cops, they'll fall back to the techniques Jeet mentioned. But in terms of this massive amount of NPCs that we can't really script or control in any way, they just wander around randomly. But there's a catch. If you let them do this, it's going to look like this sort of big ball of chaos, and confusion and general chaos will reign, and you don't want this. So we tend to also use flow patterns, but fundamentally we treat them more as low-velocity escalators. They sort of hint to the NPCs, hey, you should move in this general direction, but we're not going to tell you the way to go. We're not going to force you. It's just a kind of a hint. What we're trying to do is prevent this sort of pacing back and forth if we have random kind of wandering behaviors. So even if though the NPC is making random choices where to go, it's sort of in a directed flow. Now, there's been a lot of papers and a lot of presentation on flow patterns, so we're not going to go into any detail on this. If you're interested in more information, you can poke me after the talk. There's one more key point that I do want to mention in terms of crowd movement, that is avoidance. A lot of people will tend to fall back on RVO for this massive crowd, and it's something that works relatively well. But I would advise that you bias your avoidance heuristic or whatever you're using towards speed modification and not directional modifications. Due to the high density of the crowd, any sort of directional changes can easily propagate and can result in a lot of oscillation or just sort of like disruptive behavior. In my experience, like slowing down characters or even stopping, which is something that RVO is really bad at doing, actually stopping the characters, will resolve most of your collisions and will look a lot nicer. And this is especially true when the player is in the crowd and he's stopping and he's fucking around with the NPCs. So we've covered movement in brief. We need to move past that. Obviously, as we've got the guys moving around, that's not enough to give the sense of a living world. What we need to do is we kind of need to make them live in this environment. They need to belong. And how we need to do that is by having them understand the environment, having them understand the context that they're in, having them understand the objects that live in this environment. That goes a long way to giving that believability. The secondary action is that we need to kind of have these NPCs interact both with each other and with the player. I guess this seems quite obvious. But given how big our environments have gotten and the complexity of our gameplay and the complexity of our games in general, this is a huge challenge. And it comes back to that first challenge we talked to, and that's cost. There's a lot of content to build to do this. So how do we convey this context to the NPCs in a kind of cheap, simple, and cost-effective manner? So Jeet and I were kind of discussing the same problem. We were super worried initially when we were talking about this talk and we're saying, I have very different experiences to you. What are we going to talk about? How are we going to get this together? And we were super stressed that we're going to have these sort of opposing viewpoints. And as we started talking, we realized that even though we had different terminologies, I was calling them extended smart objects. He was calling them contextual actions. We were fundamentally describing the same technique, one whereby we take all kind of environmental contextual AI and we pull it outside of the character AI and we embed it in the environment. We would annotate the environment with all of this context. And this kind of actually, once you do this, you get a host of additional benefits. And this is the approach that we want to cover today. So, having different terminologies would get really confusing, and we kind of played around with a few names, and we came down with this. So we're going to call them external actions. And some of you are probably wondering right now, it's like, hey, you just described smart objects. What did I fuck up now? Whoops, there's a missing slide. Shit happens. So we have an external action. How is this any different from smart objects? That's a good question. It's not. It really isn't. What it is smart objects plus. It's basically an extension to the paradigm of the smart object approach where you would take AI, you would drag and drop it into the level, and it would systemically react to the environment around it. The fundamental difference that we have is one where it's one of complexity. Smart objects traditionally have been a little bit simple in their execution. And what we're proposing is a system where you can have any sort of complexity to these objects as much as you would need. So let me just describe what an external action is. Oh, son of a bitch, it was the next slide. Oh, well. So what an external action is, it's basically an object that contains all of the AI behaviors, all of the sounds, and all of the animations needed to perform any kind of role or action in the environment. It additionally has something we call a context, which is basically a set of conditions that apply to what NPCs are applicable for this object. For example, is it male, is it female, is it a cop, is it a vendor? And additionally, we have a spatial link, which defines its position in the world. So you can imagine a bench in the world to which we can attach a external action that says, hey, I can go sit down and have a smoke. So an NPC can see this object, go to it, sit down, smoke, get up, walk away without ever knowing what a bench is, what a cigarette is, none of that. And that was the slide. Surprise. So yeah, I basically covered this. I'm going to just say, in briefly, the core is that we take the extended behaviors and we push them out into the environment. Now, there's also one more thing to mention, is that we're talking about relaxed environments, particularly here. But this approach extends to any sort of environment. As I mentioned, it be as complex as you want. which means that we can basically extend this to, let's say, a combat turret or a tank in the environment. All these can be external actions that an NPC can discover in the world and use without ever having to know what they are. So why would you want to use these external actions? The first thing is reusability. As I mentioned, we have a lot of these very kind of specific environments. In terms of what we were doing in Hitman, we have these one-shot environments like hospitals, gyms, airports, which have very specific context and very specific behaviors that only exist within that environment. It's not something we can put in the core AI, right? It's not something we can kind of dump in there and hope it works. So, it makes a lot of sense to pull this stuff out and just have it in the environment. Now, if your company actually invests in IK and runtime retargeting, you can take one external action that is very generic, like leaning against the wall, and you can apply it to all of your levels, because it doesn't matter what the context is for this action. And if you have runtime retargeting, you could take that same action and apply it to all of your character types. Male, female, short, tall, it doesn't matter. Now, what runtime retargeting is a technique where you take an animation made on one animation rig, and at runtime you transcribe it to another animation rig. And 90% of the time, that works pretty great. Now, there is sort of this myth going around that it's too expensive to do at runtime, and that's not true. We've shipped games on PS3 where we were actively doing this on our characters. So if there's one takeaway you should leave this talk with, it's this. This is a myth, and it's busted. You need to, I hope that, especially now on the next-gen consoles, it's something we'll see a lot more of, and we'll get a larger variety of characters. One of the biggest benefits, in my opinion at least, with regards to these external actions is the fact that they can empower your level team and your designers to build the setups they want without a programmer holding their hands. We need to kind of move away from this code-centric AI approach, and we need to push all of this out into data. The more data-driven systems we have, the better things work, but this does imply an investment in tooling. But for a lot of us, we're dealing with legacy code bases where this is not feasible. So even if your AI is fundamentally still code-based, you can still get a huge benefit from the external actions. Fundamentally, in terms of parallelizing your production, you can have multiple teams. For example, the airport team, the gym team, and the hospital team all working in parallel, building the external actions they need for those levels. All while your core AI team is building the combat and the investigation behaviors at the same time. You could even have a third team building completely generic environmental actions that can be used across any level that you want to do. This is huge in terms of production and huge in terms of games that have a post-launch component. Something that's like you're doing DLC, or you've got a MMO where you're kind of doing constant updates. This is a massive way to kind of parallelize your production and produce content cheaply. There's also a further benefit that it does localize your bug tracking. So if you have errors in the one external action, you know it's there and it's not in the core AI. So that'll kind of reduce the bug juggling you do. So if we take all of the stuff that I just covered and we put that all together, it's got a huge potential to reduce the risk and the cost of your productions. Now, it's all well and good. I've been talking on about this pretty badly so far, it seems. But it's worth going to implementation details a little bit and to show you how this actually works in practice.
All right. So in Just Cause 3, we'll look at sort of an implementation of this in Just Cause 3. We implement the idea of external actions through a game object known as a context action. Now, a game object, you can think of it as like your sort of basic object that your engine understands you can update. What we then do is we build these hierarchical entities that include these context actions to add the ability to interact with them and add context into the environment. So here's an example of an entity that has an instance of a context action to lean on the wall. Now, this could be included into the entity for all walls and then into the entity for buildings. As soon as an LD places a building into the world, we get all the lean on wall actions. And then this can also be enabled and disabled by the designer on a per instance basis as needed. The contextual action is made up of a couple of components. The first one is what we call an interaction object. Now, this object describes the interaction itself. Abstractly, what we're trying to do is describe what the character should actually be doing and how to update the motion of the character within the interaction. We do this through the use of an interaction graph, which just has a bunch of sort of points to kind of indicate where the most interesting parts of the interaction are. It also then links to an external state machine. Now, this defines the state flow as well as all the animations and sounds that we need to perform and interact with the interaction. And we can all of this is external, and we can load this in when needed. Finally, it points to an external behavior tree. Now, this defines the behavior to be performed. This is the thing that we inject into the core AI, and this abstractly describes sort of the how, right? We want to kind of, let the NPC know how it's going to kind of interact with this thing. And the key point here, as Bobby's also mentioned, is this can be as complex as we need it to be. Finally, we include a set of properties that define the usage context, and this refers to sort of the when and the who can perform this action. You can see a couple of these examples here. We have like a search range for the action. When will this action actually be valid? How close do I need to get to it? The number of occupants that are participating in this action. Cooldown timers for when I can get this again, things like that. And all of these can be tweaked on a per instance basis. All right, so we've got our awesome external action. We need to now integrate it into our space. So as you'll see later in both our usage examples that we talk about, there are several ways we can actually do this. The first way is to directly integrate it through the environment itself. Now, the Just Cause engine organizes our spaces and environments into what we call locations. A space can be made up of multiple locations, and external actions are now placed in these locations, with each location loading in only the external data that it needs. So here's a quick example. One thing I want to also mention is that different locations within the same space can be linked up to things like game progression. We can also link it up to things like time of day, or specific game events that a game designer or game scripter can send from the game script. Now here's our town, example town, from Google Maps. And we can have sort of two locations associated with it, right? We can link it to the time of day. So during the day, the location system will bring in the daytime location, and with it, all the external actions that are placed in the daytime spot. So if our town included a bench entity, then the sit on bench external action becomes valid because it's part of the daytime location. It gets loaded in, and there we have it. It's there for NPCs to use. At nighttime, however, the location system will bring in the nighttime location, with it all the nighttime external actions. And now that exact same bench entity would enable the sleep on bench external action as opposed to that sit on bench external action. And now, this location system way of sort of integrating external actions is mostly linked up to actions that are placed through the environment with these pre-made entities. Placing external actions this way is actually very memory efficient because we can balance the load of content we need in memory by spreading across sort of all of the external actions within locations at decent spots for streaming to handle. We only load in the data that we need at any given time, and so it keeps our memory in check. All right, so Bobby really wanted to sort of talk about a few animation issues when it comes to integrating external actions that drive both of us kind of insane. So we've limited this to sort of one slide, and here it is.
Cool. So I guess a lot of you have probably seen this in games. When NPCs try to interact with objects in the world, we tend to kind of see a lot of the sliding to the spot to start playing the animation, or even worse, we'll get a lot of animation popping, especially in terms of interruptions. You get like post pops, you'll get jerks, that kind of thing. It's something that really bothers me, and something that I think we can do a lot better. There are some solutions to this. One is that we do have this weird assumption that we have to hit points exactly in our pathing, especially the endpoints. That's not necessarily true. If you animate not to full extension, and you kind of hit the endpoint with some sort of degree of tolerance, like maybe 5-10 centimeters, you can fix up all the contact points with IK. So you don't have to have this exact positioning and then slide to wherever you are off and then kind of play the animation. That's unnecessary. There's another technique is to actually hit points exactly if you so want to with animation warping. And what that does is it actually warps the trajectory coming out of the animation to reach those points exactly, based on where it's good to actually warp it in the animation data. None of this is actually a silver bullet, especially in terms of interruptions. Sometimes, depending on what interrupted, why it happened, that kind of thing, there's no way to kind of cover this with tech. And there's no way of getting around doing the content. We just have to make that content. And this is why I keep saying that we need to make this content in a smarter way. If you're actually interested in animation warping, and it's a really cool topic, Jeet's doing a main conference talk at Wednesday at 5. I definitely recommend checking out. I think it's going to be really awesome in terms of that. And that was my little aside.
All right. Well. So how do we leverage the idea of external actions in a game? So to further convince you that what we're proposing is nothing short of awesome, Bobby and I want to walk you guys through some very specific usage examples. And what you'll notice is that many of these ideas apply to sort of the, both scales. So in Just Cause 3, we have these two key focus areas, one of contextual awareness, understanding, interacting with the environment, and one of staging and driving the narrative sort of in-game. So we can categorize all the external actions into three very specific categories that meet these game-specific needs. They are systemic actions, direct spawn actions, and multi-character actions. So, systemic actions. Now, systemic actions, basically what differentiates them from all the other ones is that they have the supporting actions to engage and perform the interaction from the core behavior systemically. And they're really useful for simply adding that sort of contextual awareness and giving the NPCs the ability to interact with the environment. They don't always need to be loaded in via some entity or via the environment. They can be hand-placed as well. Something like, hey, just stand and look at this thing. A primo basic example of something like this, or a structure that describes an environmental action such as leaning on wall, would include an enter, a loop, and an exit. Now, this is very basic stuff, kind of like the sim stuff. Relaxed behavior then becomes, hey, let's move around, let's find an action to perform. Based on its usage criteria, I'm going to reserve it, I'm going to move to it, and then I'm going to execute it via the enter state. The external behavior of such an action would simply say, hey, for whatever predetermined user time, let's loop this action and lean on the wall for whatever time. And then once I'm done, exit me back into the core AI, into locomotion. Key point is that this bit, the enter, loop, and exit, is external, both in the state machine, in the behavior tree, all of that. And we can make this as crazy and complex as we need to. All right, so here's a simple example video of a lean on wall. You got the guy walking around, now he's going to enter it to lean on the wall. He's going to whatever predetermined duration, then he's going to exit, right? The thing I want to mention again is like the complexity, right? So another example of this we have is what we call our patrol external actions. Now what they define, the patrol external action would also include the path to patrol on, the behavior to execute. Hey, do I want to loop this patrol? Do I want to stop at predetermined spots? Do I want to play different animations at those spots? All of that stuff, but the general architecture remains the same. The core AI can also choose to interrupt each of these states at any given time. We're going to cover that a little bit later. All right. So within our systemic category, we also have what we call linked systemic actions. It's important to note that these are just another external action. But instead of describing their own interaction, they just point to a bunch of other systemic actions to do. And this is really useful for injecting purpose within the scene and for realizing role-based behaviors really easily. So let's see a simple example. We've got a bunch of external actions, a bunch of AI walking around. Normally, if these were just regular systemic actions based on their usage criteria, any of them could be reserving and going and executing any of these external actions. But we add a linked systemic action, and then we link up a few of these external actions to this guy. Now, any character that finds this linked contextual action, or external action, in the general systemic way of whatever its usage criteria was, will now pre-reserve all of the other little guys, and now they're exclusive to him or her. In the case of a role, we can simply assign that linked systemic action to the NPC. And now the external behavior can decide how we want to actually interact with all these other little external actions that we've placed in the world. A few examples of usage in this case are how we realize our compound behavior. So a compound behavior is simply an NPC that has a compound, part of his house. We add a whole bunch of mend the wall, rake leaves, lean on wall, take a break, sit on a bench. And it would make no sense for somebody else to come into my compound and start raking my leaves. So in this case, we use a linked systemic action. We let the NPC just find it, and then those are his or hers to do. In the case of our vagrant or bum behavior in the world, we use the exact same thing. But in this case, we have, go through garbage, walk or stand and start, talk erratically, whatever. And in this case, the external behavior is now simply looking for them, and then is randomly going between points, not sequentially like in the compound behavior. And so you can choose whatever external behavior and whatever complexity you desire. Once this type of entity has been created as a template, you can just drag it into the scene, and an LD can decide to extend it. Say some other parallel team goes, hey, I got another cool one that you could try to use. We put it in, we add it to the link, and we're good to go. It's really easy. This is a really easy way than sort of constantly having to either add more usage options or change any code. All right, our next category of external actions is what we call direct spawn actions. And this is where the NPC spawns directly into the action with the external behavior and all the states ready to go on spawn. We do this for actions that you wouldn't do systemically, for staging and scene building, and for complex interactions and encounters. This is very much tied to our spawn system and the various spawn types we may have. A simple example of a direct spawn action could be a civilian that's crying on spot. Now, you wouldn't just walk about and then suddenly systemically start crying. An example entity of such would include an external action, as well as the usage criteria is now switched out to include a spawn rule, which then has a spawn chance or an event, as well as tags to define sort of who is going to spawn in. These rules can be as open and specific and are very flexible. So let's say if we drag in a stand and guard direct spawn action, here we never want a civilian to actually spawn into this action, but we may not care about what type of enemy or military guy spawns in. So the spawn tag here simply says, hey, I want a military character to prop up. And so this adds a level of variance within the environment with very little tweaking and tuning. So here's an example of a more complex interaction where we have a military car with a soldier that's spawned directly into the turret of the mounted gun, and then another that's simply leaning on the side of the car. The entity would spawn in the vehicle, both NPCs, both external actions that are part of the entity, kick off all the setup, and we're good to go again. The external behaviors as well are completely separate. The guy in the turret is actually scanning and looking for other passerbys that are walking around, and the other guy is just leaning with the duration technique. There's no interaction between them at all. They're running their own behaviors. Agents are completely separated. Now, if an LD just wanted to have a turret guy instead in another situation, he can simply decide to disable the lean on car external action within that instance of the entity. And again, he's good to go. Our last category of actions are the multiple or the multi-character actions. Now, the paradigm we follow includes sort of this parent-child or children relationship. The entity includes the external action, as well as the spawn rules that spawn in all the individual components that make up the whole interaction. And some examples are, say, a guard that's frisking a suspect, or two people that are sitting on the stairs having a conversation. In the most simplest case of a parent and child interaction, the external action links up the parent and the child, and the external state machines of the parent dictate positioning and syncing of animations together. However, the character agents are running their own behaviors. Parents have no knowledge about their child or children, and this works surprisingly well. So here's a relatively simple example of a soldier frisking a suspect. In more complex interactions, the parent behavior tree can actually send whatever actions it needs to its child or children just via the external action. And we realize all our conversations and our encounters this way. Combining these types together allows us an extremely modular approach to staging and scene building. For example, you could have this simple frisk suspect entity, which then also includes some systemic actions for standing and observing that other people will pick up. It could also bring in a direct spawn external action to have someone standing and crying nearby, which kind of builds this narrative of this guy's upset that his friend's being frisked. And then if you wanted to reuse that crying and standing nearby direct spawn action with something else for whatever staging, like another guy preventing someone from entering a house, the LD can simply choose to do that in that instance of the multi-character external action. Now, you may think that direct spawning action seems repetitive, and it's linked directly to the chance and location. And this is kind of the case. So to counter this, we extend the idea to include what we call a direct spawn group. And this helps create a cause and effect narrative, and it's kind of similar to the link systemic actions, but it's kind of driven by the spawn system. And we can use any type of direct spawn action within the group, either an individual, a complex version, or the multi-character version. So here's our example of our Google Maps town. We have 3 external actions here. We have a checkpoint external action where you have an NPC, military dude that's observing cars as they go by. He's just watching around. Another one where he's relaxing and taking a break, leaning on a wall. And then a third one of a complex multi-character setup of a vehicle that's been pulled over and he's frisking or interrogating the suspect. The spawn group gets put in, and we include all of these external actions to that spawn group. Now we leave it up to the spawn system to, based on whatever spawn chance parameters we set up, bring in these actions one at a time. I come into the town for the first time as a player, and I see this guy. Okay, he's observing, looking at cars as they go by. I leave and I come back, and now I see, whoa, he's pulled over a vehicle. Now he's interrogating a civilian. And then I leave and I come back, and the spawn group decides to actually have him just lean on the wall. And now I've sort of built this meta-narrative within the game very easily of kind of showing some sort of cause and effect happening, trying to break up that constant repetition of this action being spawned all the time. The final case is what we use the same tech to realize an aspect of our open world encounters. And the idea is to use what we call sprinkle spawning, where we dynamically spawn in direct spawn actions along the roadside. Now, we use this to drive some of our dynamic gameplay encounters, as well as simply stage things that happen along the road out in the open world. And this is a really cheap way to populate the world and sort of those connections between spaces and areas that are around the player that would otherwise just remain empty. So we've been building that relaxed behavior. Now we've extended it to use external actions that are executing their external behavior trees. And we can either directly spawn these in using direct spawn, or they can find and use them. And the AI, the core AI, has no real knowledge of what the NPC is doing. They always take priority over the general roam-around behaviors. Now that covers up some of the use cases that we've encountered, and I'm sure we could come up a few more. One more.
So Jeet said that these were the 3 cases, and I kind of just want to do the infomercial thing and say, but wait, there's more. We have these 3 more categories, and they're primarily useful for crowd situations. That's not to say they don't apply for the regular kind of smaller scale setups, but they're primarily useful here. The first one is a simple area of effect. It's just an external action that has an activation area. These are primarily useful for things like crowd attraction, or to do something like adding environmental context or flavor to your worlds. So I think the best way to explain it is with an example. Imagine we have a crowd scene, and there's the blue dot's an environmental action, external action that's been set up to provide a sort of an area of effect, but it's not active right now. If all of a sudden a juggler comes in and he starts using it, we trigger this area of effect, which acts like a crowd attractor, and then we start pulling crowd in. Now this crowd will come in, it'll start jeering, it'll start booing, maybe they'll get bored, and they'll play different reactions, animations, whatever, and they'll come and go as they please. This is a very quick and easy way to set up these kind of organic crowd setups where you have your crowd filtering to the level, and all of a sudden they're going to get pulled over to one side and do something, and they carry on along their little flow patterns. Another thing I said was the sort of the flavor. And imagine you have like a very grimy city, and all of a sudden you have all these sewer grates that are open, they kind of smell bad and that kind of thing. You can just place these environmental actions there that have this sort of area effect, and as NPCs come through, they kind of stop and they're like, oh God, what's that smell, and just walk on. And as the player's going through this world, he sees all this little meta-narrative happening, saying, oh, the city's a bit scummy, and this is super cheap to set up. You could probably do this in like 10 minutes. This sort of leads us to the more complex case, and that is the multi-state action. And this is sort of the meat of these kind of big scenarios. It's basically an external action that internally contains some kind of a state machine that can switch the logic and the state of the actual internal action based on the context and the environment. They're very useful for faking complex social interactions and environmental behaviors. And they can be so complex that they can contain an entire multi-agent AI system within themselves. So the best way to do it is another example. Imagine we have a simple porta potty. And now we've got these 2 zones. The one is the detection zone, which is when an NPC enters this, he can detect the external object exists and decide whether to use it. And then we have something called an acquisition zone. This is a zone that only once an NPC enters this does he actually take ownership of the external action. We don't want to have this line-of-sight resource acquisition model, because you end up having one guy acquires it first, and then a guy that gets closer is now blocked, and he kind of can't use the thing, even though he's right there. We want to kind of avoid that. It looks a little weird. So imagine he walks up, he goes to the acquisition zone, he uses it, he acquires the object, and he uses it. Simple setup. Now, in the multi-state example, we have two guys. They both see this object. They both start walking towards it, but one guy gets there first. And as soon as he enters that acquisition zone, we flip the state. And we trigger a sub-external action, which is a queue volume that an LD has set up saying, hey, I want them to line up here. And now what happens is we forward that second NPC to the queue object, and he's playing the external behavior of the queue, even though his core behavior still thinks he's in the porta potty example. And as more guys enter the detection zone, they simply line up. And you have this kind of like complex behavior in a very simple way. So as the guy finishes, we sort of empty out the queue, and then what happens with the object? We're back to the original state. Now, we use the porta potty. Now, imagine I had a bar. I could use this exact same external action and hook it up to a bar stall, or I could hook it up to a bush. And we've got all this kind of reusability across all of our environments with one setup. And that's kind of cool. There's also another example. Let's say we have this setup here with a fireplace in the middle of a room. And basically we have NPCs can go up, they can warm up their hands, and they can sort of leave, and we have all these usage spots. Now imagine that two NPCs line up next to each other, and we have a rule saying, hey, if two guys are adjacent to each other, we switch state, and then we trigger a conversation. That makes sense, right? You can talk about hand egg or whatever you guys call not soccer. And you can have this very kind of cheap environmental interaction here. But it gets even better because we can take that same fireplace and say, hey, let's add another state to it. What if the player can mess with it and turn it off? Now I can have an NPC walk up to it, turn it on, warm his hands, and walk off. So now I'm adding functionality to the single object in the world without messing with the core AI. Obviously, we can take this even further. And you can sabotage it. You can say, cool, now as soon as he goes in, boom, dead. Cool, now we have death. And that's always awesome in our kind of games. And we have this, all this on one object. And even on top of that, we say, let's do an area effect, boom. And now another NPC goes in and says, whoa, man, that thing's scary. I'm going to avoid it. And now you have a meta-narrative saying, the NPCs know what happened in the world. They observed that this thing blew up, it killed a dude, and now we're going to stay away from it. And it's all fake. It's all smoke and mirrors, and it's all super easy and cheap. Now, the last thing I want to cover, and this is very simple, it's dynamic external actions. This is an external action that's spawned, but unlike the stuff that Jeet mentioned, this is spawned dynamically at runtime. It's not pre-set up, it's not authored, it's not anything. It's just, poop, it happens. Good examples of this is stuff like once-off secondary actions, like answering a phone while you're walking, or if there's a big fire, then you have fire spreading and external action attached to that and people fleeing. Now, there's a question of how do you spawn this, and there's no answer to this. This is entirely dependent on your gameplay and your setup. You could do gameplay setups like, if an NPC runs and he hits a button, and then alarm internal actions go off all over the entire level, and you have everybody reacting to that. You do that with an area of effect, for example. Or you could actually go even further and build an external action director that will spawn these based on, let's say, the player's moving around and nothing interesting's happened in the last 5 minutes, so they would spawn these things on the ground. There's one thing to keep note here is that these spawned actions have to be hints. Don't ever sort of like spawn this thing and force a guy into it, because you don't want to end up in a situation where there's like a fire raging and you have a dude tying his shoelace in the middle of it because the director spawned a tie shoelace action. So imagine that we have a big crowd scene and we have like the player walking through it, and all of a sudden we say, nothing's happened, so let's spawn a cell phone call. We spawn the action, and one of the NPCs says, hey, I see this thing, I'm going to use it. And he goes to it and he says, let me answer my phone, and he has a conversation. It looks cool, Player says, oh, okay, this guy's living his life, I'm going to go past it. And then we spawn something else, like a conversation. And all of a sudden, these two guys go into that, and they start talking. They're like, man, did you hear this dude blew up when he was trying to turn on this fireplace earlier on? And you can, again, build meta-narrative with these sort of setups very easily. Now, we sort of covered a lot of examples of how to use external actions, how to integrate them into the level. And we've covered some of the challenges that we mentioned earlier. There's still one challenge that we need to discuss, and it's a very important one, and that's simply variation.
All right. So repetition is a shared challenge for both scales. The behavior always tends to feel either synchronized or repetitive. And what's interesting about that sort of smaller scale is that this becomes very noticeable when you can identify the number of NPCs that exist. A solution could be, hey, let's add lots and lots of content, and that's fine, that's valid, but that comes with the cost of production time, memory, and there's an interesting thing that happens as well that we encountered, which is it becomes unnatural. there's only so many ways that you can actually lean on a wall after it really starts standing out. And so the idea is to make these things variable, but not have them stand out where they're so specific that you can't reuse them again. Then you're taking away from the reusability. So the way we choose to handle this problem in Just Cause 3 is using the idea of animation masking and using secondary actions and secondary behaviors to vary our core sort of relaxed situation. The advantage of this technique is that we can extend this idea to all our relaxed behaviors, moving, entering external action, looping it, whatever. So if we look at this video that's playing over here, we've got 3 guys that are on the sit-on chair external action, and they're, playing the exact same animation. Now, if you imagine a group of, say, 20 NPCs in this space, this is going to really stand out like a kind of triplet situation. So what we do is we mask out animations. This allows us to mask out base full-body content into building block chunks, which we then reassemble in our state machines at compile time. This adds no additional cost at runtime, and it keeps our memory in check again, because we will never see any duplication of content. Here, in this animation now, it's the exact same one, but we switched out the arms to either be crossed. We can switch out the legs to be crossed as well, change the position of the arms and things like that. For more information on this, I'll be also covering this in the talk in the main conference. Now, the other kind of simple thing we can do is we can just offset the time of animation. This is covered a lot already. So now we've got the masks going. Now we've changed the timing of when we actually started the animations that ends up varying them significantly. Finally, along with this, we can add what we call secondary actions. And these are actions that we play in parallel with our base behaviors. And it's very useful sort of when we're performing external actions or when we're moving around. It's a highly reusable sort of bank of animation masks that run in parallel on a different layer within the animation system. And they're really cheap and quick. So, you can just scratch your head, you can cough, you can sneeze, you can swat flies, whatever, you can build that can apply in those situations. And this adds a ton of variance into the scene for very cheap. Finally, we can extend this idea to take on behaviors as well. So with the secondary actions, we can actually kick off secondary behaviors in parallel. Things like pulling out your cell phone and actually making a phone call, looping that for a while, whatever that behavior tells us to do, and then putting it away. Now, the key caveat here is that you want your sort of underlining relaxed behavior to decide what the validity of these secondary behaviors are. Things like pulling out a book and reading a book for an extended period of time works perfect on a sit-on bench. It doesn't very much work when you're driving a car, for example. So how do we now take this and deal with scale when our NPCs start to become a crowd?
Cool. So I think this may be a bit obvious, like specific movement in the crowd is lost. It's lost in the crowd, so to say. So there's no really, a lot of people kind of say, oh, let's mocap some more walk cycles for female characters, or let's mocap some more kind of flair for the guys, and that kind of stuff gets lost. It really does get lost, and it's a waste of content. What I would suggest you focus on rather is just visual variation. Focus on different body types, different heights. Heights is super critical. Different skins, do different colors of clothing, do hats, do props, do silly things like that. What I'm actually saying is less of this and more of this.
All right, so we now come to our final sort of reacting to the world section. And this is a huge, part of intelligence and believability. And, I think we both agree, Bobby and I both agree that this quote is super important when it comes to these behaviors. If the world ignores the player begins to ignore the world. This is not a situation you want to get to, especially if you're building an open world game. Now, in Just Cause 3, this was increasingly important, and we couldn't really cut corners because the player is capable of doing these sort of fantastical things. If a parachute sort of zips by you or you land down from wingsuiting and nobody looks at you when you do this, it completely breaks the immersion of the game. In addition, we have to deal with varying levels of interest as well, and 360 degrees of interruption. So, unsurprisingly, our first level of awareness is a simple look at. Now, this behavior is run in parallel with all other relaxed behaviors with some exceptions. And some examples of this systemic awareness are things like NPCs passing by each other, or fast-moving cars that zip you by as well. How do we actually realize this? Now, since we need to support this in most, if not all, relaxed behaviors, we need to use an animation mask that stabilizes the head and chest. And the reason for this is we don't know what the external action or the sort of relaxed behavior, be it moving or whatever, is really doing. The core AI doesn't know that. So imagine if you were sitting on that chair and looking around. Now you want to look at something here. The first thing we do is we stabilize the head and chest, and then simply on top of that, we run an IK solution to follow and track the entity. Now, it's important to note that actions and behaviors can choose to enable and disable this simple look at, handled via the external behavior tree communicating that meta information to the core AI. This is, for example, if I'm frisking a suspect and I just see another NPC walk by, I don't really need to look at that NPC. This is the first level of awareness that we can always fall back on if we need to. Right, but what happens if the player does suddenly parachute through the space, or we have a fleeing civilian that runs through the space erratically? And these are very common occurrences in Just Cause 3. And in those cases, we need the AI to be aware of these types of events that are very linked to a specific action happening. And we define these two events via either the state. And in this case, we include the metadata on how to respond to them. So a few examples of this is a civilian gets shot, he plays a hit reaction, and from the hit reaction state, he sends off this awareness information, these awareness events as metadata of how to actually respond to it. The second type is visual events, and this is driven completely by the NPC itself via its vision system to look for things like a dead civilian that's lying around, or a civilian that's been grappled up onto a tree. A quick note on propagation. We also define these ranges where the states themselves can say, for this action, this is the range to use, and then can send multiple versions of these for varying levels of interest. To handle sort of the close range edge cases, we use a broadcast propagation technique where anybody that's choosing to react or observe will also then send off a little mini sort of broadcast in to say, hey, I'm also looking at that, maybe you should too. Okay, well now let's turn our attention to the response. On receiving the awareness event, that event includes the metadata on whether or not the action that takes place is either interesting or dangerous. If it's dangerous, well, we're going to mental state transition out of relaxed, and that's a whole different talk. But for now, if we're going to stay interested, we need to focus on action persistence. And you could choose to basically say, okay, well, why don't we bail you out, respond, and then do whatever you want after that. And for Just Cause 3, this was kind of a problem because these occurrences, these interruptions can happen so often that the scene was getting disrupted completely, even by a simple sort of the player reeling his grappling hook and landing on the wall. And so we really need to kind of tackle this. And to be honest, people don't really do that. They don't really change their action immediately just because something small happened, right? So we need to focus on action persistence. All you need to do is you need to pause your current behavior, do something meaningful in parallel, and then resume the behavior if it's applicable. So if you remember our core behavior stack, here's our layer of awareness. We're going to evaluate the awareness as a higher priority rather than the core behavior in parallel. And then we're going to process that awareness, followed up by either a reaction or a look at, again running in parallel within two priorities. And it's important to remember that we need to build this up so that the core AI still has no knowledge of what the NPC actually is going to be doing. The reaction and response as well needs to be handled in a systemic way. All right, so once the event is received by the NPCs, based on the actual metadata of whether it's interesting or dangerous, we need to interrupt this behavior. And the trick is to leave it up to the current behavior to decide. If you're basically just moving around, we simply allow it to be interrupted by the next behavior. If we're in an external action, then each individual action can choose whether to ignore it, if I was in the frisk suspect situation, for example, to fall back to a simple look at if I'm doing something like lying on the beach completely flat, or basically play an interrupt animation that is actually part of the external state machine to bring me to a pose that I can then play sort of a general reaction that's part of the core AI. So we leave it up to the responsibility of the current behavior to help set up the core AI. After that, we simply vary the reactions, play the reaction within the core AI based on intensity. Even though they are variable, we standardize them, and we let this be data-driven by our designers. Then we follow an observe and investigate behavior, and then choose to re-resume. In the resuming case, since our mental state remains relaxed, the simplest thing is to let the behavior decide again. Each behavior, external or otherwise, once it's unpaused, rechecks validity, and then simply re-executes and re-enters. So once the AI is done processing the awareness, it makes a request to resume the behavior. If moving, we simply unpause locomotion, and we go to our previous location, the same pathfind that we were going to. In the case of external actions, we can re-enter either through external state machines. In the case of systemic ones, you go back to your previous systemic action the same way and re-enter it. Direct spawn ones, we can either use transition animations, or once the character goes off screen, we can simply push him back in. And complex ones, we leave it up to the external action to make sure that it receives notification from all the parents and children that they're all ready to go. You go off screen, and we restage all of them in one shot. This leaves all our characters independently, again, running their own core behavior. All right. Well, I think we've covered relaxed behaviors, interacting with the environment, and reacting to the behaviors. And that sort of wraps things up.
Sorry, we ran a little bit over. But yeah, we're just going to leave you with a few things just to kind of take away from this talk and just, kind of just take home with you and see what happens. And start off with these things.
External actions.
Those are awesome. And that's it. I don't know if we have time for any questions. I think not. 2 minutes. 2 minutes for questions, if there's any questions. I'm just going to go back to this.
Oh, seriously, folks? Come on.
Cool. Thanks. Oh, wait.
There's one. Hang on.
No,
So sure, I have a question. You talked a lot about what you did, and obviously this project is not like this year new, and you probably thought about the process. So how would you improve this process if you had to re-implement it in a new game with a similar budget and team?
I mean, the way I would improve it,
No more questions.
I would say the thing is start early. I think what we ended up doing in our case was we waited a little bit too late to start building the content. And if you have this framework already set up, like Bobby said, kick off multiple teams that are simply building tons and tons of content for you that you can reuse and modularize. I think the other big thing to remember is to educate your designers on kind of using these things very modularly.
For me, honestly, I don't think I would change much in terms of the core approach. I think that's still extremely solid. And I still think I would use that moving forward. What I would focus more my time on is by kicking off the designers and focusing on more core tech things like fixing the animation issues, because that is a huge immersion break. I could have the coolest AI in the world. If I have retarded animations, then it breaks all of that hard work that the guys have put into it. And I would actually focus on more, all these games come up with really good graphics, and then sort of the behavior maybe breaks it for you. And this is what we need to we need to get the animation quality to a level where it's in line with the graphics, so it's not a problem anymore in terms of player experience.
Thanks, great talk. Could you talk a bit more about the process of prioritizing the core behavior with the external actions and that side of things?
Sure. In terms of prioritizing the core behavior in a way is simply running those little sub-behaviors stacked up. So priority-wise, like I said, moving around becomes your sort of base priority. And then once you find an external action to do, you're no longer roaming around. You now have purpose, and you're going to move to that external action as your higher priority thing to do. In front of that, if you were directly spawned into an action, then you're not even going to look around, look for things to do, because now you're kind of fixed in that complex interaction or whatever. And then in parallel, you got things running like the look at and the response or reaction. And then you kind of need to make sure that whatever's happening here is sort of communicating back and forth with the relaxed behavior. I don't know if that answers it.
Yeah, thanks.